Hi everyone, the channel Easy Lecture welcomes you. So I have decided to start a series on the subject signals and systems, and today is the first topic of the subject, and the topic is types of signals. We are going to discuss that topic in this video. Before entering into the video, subscribe my channel Easy Lecture. Now let us go for further discussion. So types of signals, it is a very important topic, and signals and systems forms the basic of digital signal processing or a digital image processing or any signal processing, because in electronics and communication engineering we have electronic devices to understand the properties of the devices. So with those devices we design the circuits, and with those circuits we use those circuits to process the signal or to transmit the signal, and the application has those applications we are using in communication, either in analog communication or a digital communication. So we are completely engaged with signals throughout our career, the electronics and communication engineers. So the understanding of signals is very important, and the basic of that is the types of signals. So what are the signals types available? And there is another category called elementary signals types. Elementary signal types means unit ramp signal, unit step signal. So those things come under that category. Here we are in this video we are going to discuss the types of signals. So when I say types of signals, it includes the categories such as continuous signal, discrete signal, energy signal, power signal, even signal, odd signal, deterministic signal, random signal. So those things we are going to discuss today. Before entering into the video, subscribe my channel Easy Lecture. Now let us go for further discussion. So the first category that comes here is continuous signal and discrete signal. We are very much aware of these types of signals, so because in another video while discussing a digital communication under the topic of sampling, we have analyzed we have done complete analysis of this continuous signal and discrete signal. We have done a process to transmit a continuous signal into discrete signal. Okay, so we know what is meant by continuous signal. So continuous signal, it is continuous, its amplitude is continuous in nature with respect to time. Here in x-axis we have time, and along y-axis we have amplitude, and that amplitude is continuous in nature with respect to time. Whereas for discrete signal, the amplitude is not continuous and it is broken. And each broken part we call as samples. Here at n equal to 0 we have 0th sample, at n is equal to 1 we have got first sample, at n equal to 2 we have got second sample, and third sample, fourth sample, fifth sample, like that it goes on. Whereas the gap between the amplitude between first sample and second sample, there is no amplitude, it is 0. Okay, so that is why we call it as a broken signal, discrete signal. We can individually take a particular sample outside, whereas for continuous signal we cannot take a particular value. Okay, for example, we cannot take a particular amplitude level at t equal to 1. For example, let this point be t equal to 1. So we cannot take this amplitude level t equal to 1 at this particular point. It will not be 1, it will be 0.99999, or it will be 1.0000. So there may be some changes in continuous signal. We cannot point the exact amplitude level. And here also along x-axis we have the variation of time continuously. It is also not broken. There is also the continuous variation is there. We cannot pinpoint the first minute. I have to take this amplitude level at first minute. It may not be the first minute. It may be 1.00001 minute. It may be 1.001 minute. So we cannot predict it. In continuous signal we cannot do that, but human can understand only continuous signals. They can the human brain, it can interpret only continuous signal, whereas we go for digital signal to process it, to enhance the processing. Continuous signal cannot be transmitted in wireless medium. We need digital signal to get transmitted into wireless medium. For that we need to convert a continuous signal into digital signal, and to do that the first step is to convert a continuous signal into discrete signal, and that is done by sampling process. Okay, so we have analyzed all these things in another topic, so I am not going further into that. Just let us be clear. Continuous signal, the amplitude is continuous with respect to time, whereas for discrete signal the amplitude is not continuous, it is broken, it is discrete in nature with respect to time. Okay, now let us go for the next type of signal, deterministic signal and random signal. So deterministic signal, as the name suggests, this signal can be determined. If we view this signal for a particular time period, in the next time period, in the next spell of time period, we can predict the signal. Okay, this signal is going to be this, the amplitude of this signal is going to be like this. So such prediction can be made. So that is that is called as deterministic signal. Whereas random signal, just that kind of prediction cannot be done. We cannot predict the future of the random signal, and random signal is otherwise called as non-deterministic signal. Okay, let us look at the next variety, and that is periodic signal and aperiodic signal. Periodic signal, it repeats after regular interval of time. So if we observe that signal for a particular interval of period, particular time period, and in the next time period, the same previous time, the same signal in the previous time period repeats itself. Okay, and the time period for which the signal is repeating itself, that time period is called as fundamental period. Okay, periodic signal, and whenever we come across periodic signal, it is mandatory to analyze the fundamental period. So what is the fundamental period of this periodic signal? So that should come into mind. We have to do that. We have to analyze that. Okay, and the next one is aperiodic signal. Here aperiodic signal, it will not repeat itself. It may be anything. It will not repeat itself. So periodic signal is a deterministic signal, obviously, and aperiodic signal is a random signal, obviously. Okay, so here we have a periodic signal. A sinusoidal signal is given as an example. So sinusoidal signal, again, when I say sinusoidal signal, there are two signals that come under sinusoidal category. One is sine waveform and another one is cosine waveform. Both are sinusoidal signal. Okay, all right. So here this is an aperiodic signal, a random signal. Okay, now even and odd signal. Okay, so even and odd signal means along x-axis we have time, and time, there is a reference line called 0th time, and the signal greater than 0 and the signal less than 0, if they are equal, if the amplitude are equal, then that signal is called as even signal. If the amplitude are in opposite direction, okay, for example, for the signal greater than 0, if the amplitude is in positive direction, and for the signal less than 0, if the amplitude is in negative direction, then that kind of signal is called as odd signal. Here we have two sinusoidal waveforms. One is sine waveform and another one is cosine waveform. Cosine waveform is an even signal. Okay, so cosine waveform is even signal because for the value of t greater than 0, we have an amplitude level, and the same amplitude level is repeated for t less than 0. Okay, so both have the same amplitude level. So that means if we keep a reflective mirror here, the same kind of reflection is observed in this direction also, in this in another part also. Whereas for odd signal, so that is odd signal means here as an example we are looking at the sine waveform. Okay, so sine waveform, here we have one signal, and for t less than 0, the amplitude is negative of the amplitude of the signal that is available in t greater than 0. So that is why we call it as odd signal. So if we represent it in equation for odd signal, it is x of t is equal to minus x of minus t. Okay, so this is for odd signal, and for even signal we will be having x of t is equal to x of minus t. And for any signal we can easily calculate the even component and odd component available in that signal. So for any signal both the components are available, that we can easily take out. Okay, so this is the equation representation of even signal and odd signal, and you should not get confusion. Here this is odd signal and this is even signal. So I have first represented even odd signal and then represented even signal. So this is odd signal, this is even signal. Here there is another example of odd signal and even signal. So here this is even signal, this one is even signal, this one is odd signal. Okay, now let us look into the next category. So this is energy and power signal. So energy and power signal, so these are the parameters which gives information about the strength of the signal, how strong the signal is. That kind of information can be evaluated from this energy and power parameters. Okay, so we need to understand the relationship between energy and power. We know that the relationship between voltage and current by Ohm's law. V is equal to I into R, current into resistor. So by the same Ohm's law, we know that power is equal to the product of voltage and current, V into I. So that means power is equal to I square into R, we know that. Okay, and what is the relationship between power and energy? So power and energy is power times the time. Okay, power multiplied with time gives energy. Okay, so in our house we are using electrical appliances, and for those electrical appliances there is power. For example, if we have a television, and the television, the operating power is 60 watt or 40 watt, and for computer the operating power is 20 watt. Then for a fan, ceiling fan, the operating power is 60 watt, and for CFL there are varieties of power available from 5 watt to 20 watt, 40 watt. So like the various power CFL lamps are available. Okay, so here the power is decided by the manufacturer, that particular electrical appliances of this much of power, whereas energy, that can be seen from the energy meter reading that is available in our domestic houses. Okay, so electrical appliances, we have energy meter that gives the values related to the energy being consumed by those electrical appliances. So here what happens, if an electrical appliance is of 20 watt, then that 20 watt of electrical appliance, if we use for 5 hours, then we can say that it has consumed 100 watt hour of energy. So the unit of power is watt, whereas the unit of energy is watt hour. Okay, WH. So watt hour, WATTHOUR. So this is the relationship between energy and power. Energy is equal to power into time. So when we use these ideas to write an equation for energy, energy is equal to E is equal to integration of minus T to T. Okay, this is for signal, periodic signal with fundamental period, or this is for a signal. When we speak about signal, we may take it as minus infinity to also. Okay, so and power into time, when I say power into time, we can write it as I square into R into T. Okay, and when R is of unit ohms, we can write it as I square into T dt. Okay, so this is the equation representation of energy, whereas power, when this energy is divided by the fundamental period, that gives power. Okay, so this is the relationship that we might have seen in a lot of books, but the definition of energy and power signal is not the definition. I don't say this as definition. The idea how to find whether a signal is an energy signal or power signal means we have to calculate the energy and power for the given signal. And for power signal, for a signal to be a power signal, the power is finite. For a signal to be an energy signal, the energy is finite. Okay, if power is finite, then it is power signal. If energy is finite, then it is energy signal. Okay, but for a power signal, power is finite, whereas energy is infinite. For an energy signal, energy is finite, whereas power is zero. Okay, so this understanding we must have to categorize between energy signal and power signal. And all periodic signals are power signals. A sawtooth waveform, a square waveform, a triangular waveform, a sinusoidal waveform, all periodic signals are power signals. Okay, whereas exponential decay signal, that becomes an energy signal. A signal can be either a power signal or energy signal. If a power signal cannot be an energy signal cannot become a power signal. Either it can be a power signal or energy signal. It cannot be both energy and power signal. Okay, this is one understanding that we must need. We must need to have. Another one thing, there are certain signals which may be neither energy signal nor power signal. An example is a ramp signal. Ramp signal cannot be an energy signal and it cannot be a power signal. Okay, so it is neither an energy nor a power signal. Okay, so just you have this in your mind. An energy signal cannot be a power signal, and a power signal cannot become an energy signal, and a signal cannot be both energy signal and power signal. Okay, so this kind of understanding is mandatorily required, and I hope already you are familiar with this topic, types of signals, but today the discussion that we had in this video, there is a chance for you to have upliftment in your knowledge after watching this video on the topic related to the types of signals. I hope so. Meet you again in another video. Don't forget to subscribe my channel Easy Lecture. If you have any comment, give that in the comment box. Meet you again. Bye.